Welcome back to learning about area, the bonus lessons that I included for you guys this year. Now, what we're going to go over today is the area of trapezoids, kites, and rhombi. All right, so find the height of a trapezoid. We're going to go over how to find the area of a trapezoid, rhombus, and a kite, and how to find the area of, once again, irregular shaped figures. Okay. So let's start with the height of a trapezoid. Now, height of a trapezoid is what? Do you guys remember? It is the shortest distance between the bases. And if you guys do remember anything from this class, the shortest distance between the bases, which are two line segments, always has to make what with the segments? Right angles. So if you make two right angles with it, you make right angles with the segments and you have your height that connects it, all right? Has to form a right angle with both bases, okay? And it can because the bases have to be parallel. All right, if I tilted this to the side, your height would still be the distance between those two bases. All right, next theorem, the area of a trapezoid. Area of a trapezoid is, you guys know? What do you think? Half, 1/2, the blank, what are you doing here? Product, you're multiplying. The product of the blue is height. And the sum of the two, what do you think? Bases. So add up the two bases, multiply it by the height, and take half of that. All right, so the formula for a trapezoid, 1/2 height times base 1 plus base 2. It doesn't matter what you represent as base 1 and base 2, just that you add the two together. Okay? Now let's look at the first example. To prevent beavers from damming a drainage pipe, trapezoid-shaped fence is shown and placed in the pipe. Obviously, it has bars in it, so that the water can still get through. Approximate the area enclosed by the fence. The height of the trapezoid is, first thing, what's the height of the trapezoid? 9, very good. The lengths of the bases are 8 and 16. 12 and 12 are your legs, okay? Remember, these are parallel, these are not parallel. So, 1/2, you're going to have the formula. You substitute in 1/2 of 9, which is your height. 8 plus 16, your two bases. 1/2 of 9, 8 plus 16 is 24. So, half of 24 is 12. 12 times 9 is 108. Do not distribute the 1/2 to both of these, okay? And that's your answer, 108 square feet. All right, remember areas, square units. Got it? Let's move on. So what I want you guys to do is find the area for these three problems. All right, let's see how you did. Problem number 2. 10 and 16 are your bases. 7 is your height. 1/2 of 7 times 26. 91 units squared. Right here, two bases, parallel sides, so that's 21 and 7. The height is the one with the right angles, that's 15. 1/2 of 15 times 7 plus 21 is 28. Half of that is 210 square units. Problem number 4. Bases, two parallel sides, 24 and 8. Height, distance between them two makes a right angle there. If it makes a right angle here, it has to make one down here because they are parallel. All right, remember, same side interior angles are congruent. Are supplementary, so if one's 90, the other one's 90. 1/2 of 4, 28 plus 24 plus 8. 1/2 of 4 times 32 is 64. All right, any questions? Make sure you email me. There should not be any questions. All right, area of a rhombus. A rhombus is blank, the blank of the lengths of its blank. There's a rhombus. Why do you think I'm doing all these areas together? Because they're very similar formulas. So it is, once again, half. What are you doing in all these situations? You are multiplying, so it's the product of the lengths of its, what does a rhombus have? It has 2 of them, because of the D, diagonals. So, the blue guy here is diagonal 1, and that's the distance from vertex to opposite vertex. And the red segment here is diagonal 2. And that's the distance between the other two vertices, opposite vertices. Area equals 1/2 D1 times D2. And the area of a kite. very, very similar formula. Let's see if you can guess it. Is, match the colors, half the product of the lengths of its diagonals. Not very similar. It's the exact same formula. So 1/2 of D1 vertice to vertice times D2 vertice to vertice. So a rhombi, all rhombi and all kites have the same area formula. So let's use it. Example 5, find the area of this rhombus. Now, PT is 8, ST is 11. I made these colorful so you guys can see. Find the length of each diagonal. So the diagonals of a rhombus blank each other. What do they do to each other? A rhombus diagonal, not a kite, but a rhombus. They both bisect each other. So since ST right here is 11, it also equals TQ. Since PT, which is 8 here, that also equals TR. So if I want to find the whole diameter here, QS, what two sides do I add together? QT plus TS, right? QT, TS, ST, TQ. Doesn't matter what order you say it. So, and they both happen to equal what numbers? 11 and 11. 11 plus 11 is 22. Could you just multiply this by 2 and be done with it? Of course you can, but this is the mathematical way to do it. PR is obviously going to be, let's see, PT plus TR, right? If this is 8, this is also 8. 8 plus 8 is 16. Once again, 8 times 2 is 16. Now we're going to find the area. Now we got our two diagonals. We're going to find our area of our rhombus. Sorry, rhombi is more than one rhombus. 1/2 stays 1/2. Diagonal 1, QS is 22. Diagonal 2, PR is 16. Substitute them in. 22 times 16 times 1/2. You do not take half of each one. You just do 1/2 times 22 times 16. Only if there was a plus or minus here between these two is when you would distribute. So you get 11 times 16, which is 176. Since this area, it is centimeters squared. That's it. See that? Already halfway done with the lesson. All right, problem 6, 7, 8, 9. You guys are going to do on your own. And go. Let's look. You want the whole diagonal since each one of these is 4. Each one of these is 3. That means it's a rhombus because it's bisecting and there's a right angle in the middle. So what do we have here? 4 plus 4 is 8. Very difficult problem. 3 plus 3, almost as difficult, is it is 6. So half of 8 times 6, 4 times 6 is 24. Now it gives you the AC. It gives you the BD. So it's very simple. This is just your diagonal 1, your diagonal 2. Since it gives you the whole diagonal, there's no reason to multiply or divide anything by it. 1/2 of 18 times 12 is 9 times 12 is 108. Right. Problem number 8. AC is 16. BD is 34. Once again, it's giving you the whole distances here. So you got your diagonal 1, your diagonal 2. All right. So what you're going to do here is 1/2 of both of them multiplied by each other. 8 times 34 is 272. And last one, number 9. Now this 13 here, that doesn't mean anything. If you weren't given the 5, you can use 5, 12. You can use the 12 and 13 to find 5 using Pythagorean theorem, but you're given this 5. This 4 over here, that doesn't mean anything either. If you were given this 4 and not given this 3, you could use the 4 and the 5 to find the 3. Wait a second. That's not 4. That's something else. This should be like 6. Even though it doesn't affect the problem, 3 and 5 right here, this is the hypotenuse, so it should be the longest side. Doesn't affect what we're going to do, but I just like everything to be right. All right, anyway, 3 and 12 gives you your first diagonal, so you add them together, you get 15. Second diagonal is 5 plus 5. 5 plus 5 is 10. 1/2 of 15 times 10 is 75. Right? Oop. All right. Let's just try problems 10, 11, 12, and 13. Problem 10. Trapezoid. Here's the formula. Height 4, Bases, 7 and 9. 7 and 9 are bases. Height is 4. 1/2 of 4, 7 times plus 9, sorry. 1/2 of 4 times 16 is 32. This one right here. 12 is just this distance. 18 is just this distance. So you have to multiply both by 2. 2 times 12 is 24. 2 times 18 is 36. Can you do these in your head? Of course you can. All right. 1/2 of 24 times 36 is 432. All right. Right here. Area is 18. Ooh, so TR is 6. How do we find QS? We're going to use the formula. Area, which is 18, so that's your diagonal 1, that's your diagonal 2, and that's your area. So area, 18, equals 1/2, diagonal 1, which we don't know, times 6. Half of 6 is 3. So 3 times diagonal 1 equals 18. How do we solve for diagonal 1? Good, divide by 3 and it equals 6. So they're both equal. So is it really a kite? No, it's actually a square. That's weird. Alright, let's go to 13. Area is 42. We're going backwards here again. Diagonal 1, we don't know what diagonal 2 is. 42 equals, so half of 8 is 4. 42 divided by 4 is 10.5. Alright? Easy, 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 easy. Want to ramp it up a little bit? Yep. Solve for an unknown measurement. So, diagonal, alright, of a kite is 2 times the other diagonal. The area of the kite is 56.25 square inches. What is the length of the diagonal? So, we did something like this before, very similar to it when we dealt with angles and we dealt with segments, just using the proportions, alright? So, one diagonal is 2 times as long as the other. All right, so we're going to do it. So if x is the length of one diagonal, what's the diagonal that's twice as long going to be? So this one's x. This one's going to be twice as long, so it's 2x. All right, now we're going to use the formula to find x. Now what's our area? 56.25, 56 1/4. 1/2, diagonal 1 is x, diagonal 2 is 2x. So 56.25 equals half of, what is x times 2x? 2x squared. What's half of 2? X. So half of 2 is 1. X times x is x squared. And now x squared equals 56 1/4. We have to take the square root of both ones to solve, and you get 7.5. See that? Now, the lengths of the diagonals are, let's see, x is 7.5 inches. And then 2 times x is 2 times 7.5, which is 15 inches. All right, and that's it. That was easy, wasn't it? 2 more. Told you, these lessons are all easy. Find the areas, go. Got it? Bases, 6 and 8. Height is 4. 1/2 of 4, 6 plus 8. Half of 4 times 14. 2 times 14 is 28. Kite. Diagonal 1, diagonal 2. Just because this isn't inside doesn't mean it's not a diagonal. It's still going to be the same length. So, half of 14 times 6 is 42. And then you got a rhombi right here. 30 is this, so you're going to do 30 times 2 is 60. This is 40. 40 times 2 is 80. Half of 60 times 80 is 2,400. All right. Ready for the last one? Last one of the day. Give you multiple choice to make it easy. 1/2 of a kite is as long as the other diagonal. If the area of the kite is 72.25 square inches, what are the lengths of the diagonals? A, B, C, or D? So, you good? 1/2 of the kite, one diagonal is half as long as the other. So you have a 1/2 x and you have a x. Where does it matter where these go? Yes, obviously the half is the smaller one. So, use your formula. Area, 72.25 equals 1/2 of 1/2 x times x. What's half times a half? 1 times 1 is 1, 2 times 2 is 4. So So this is 1/4. X times x is x squared. Now, in order to solve for x, how do we get rid of a fourth? You multiply by the reciprocal. You multiply both sides by 4. X squared equals 72.25 times 4 is 289. Last step is to take the square root. You get 13. Oh, 17. Duh. So you get 17. So, x is 17. So, wrong, wrong, up. Only answer could be. And you get half of x. Half of 17 is 8.5. C is your correct answer. Well done. So that is area of a rhombi. 1/2, diagonal 1, diagonal 2. A kite, 1/2, diagonal 1 times diagonal 2. And a trapezoid, 1/2, the height times the quantity of the sum of the bases. All right. Hopefully you guys learned something today. And if you didn't, go back, try it again. Until the next area thing, goodbye.